Take a look at this simple truss. Let us determine the member forces of this truss using method of joints. You know how to solve this problem based on our earlier discussion. Typically, we will draw the free body diagram of the entire structure, calculate the support reactions. We will then draw the free body diagram of each joint and calculate the member forces. Some of you may even start with the joint instead of drawing the free body diagram of the entire structure. For example, joint C in this case where there are only two unknown forces. I encourage you to pause this video now and solve this problem yourself for all member forces using method of joints. It should not take too long to solve this problem. Okay, I assume you have solved the problem. You can now continue with the video to verify your answers. Your analysis should show that members CD and BC do not carry any load at all. These members are not in tension or compression. Such members are called zero force members. You may think why we need such members if they don't carry any load. In reality, you often need zero force members for many reasons. 1. Often they are there for maintaining structural integrity. 2. Increase stability of the truss. 3. Provide support if there is any change in the loading condition. And finally, sometimes zero force members are added to make a truss structure look nice. I will discuss this when we solve more problems later. As you can see, if there is a way to identify these members without drawing free body diagrams, you can speed up your calculations. This also helps to develop a better understanding of trusses. It turns out we can actually identify zero force members by inspection, just by looking at it using a few rules. So let us go over these simple rules. These rules are easy to remember and apply. You will get good at it if you practice this a few times. In the worst case scenario, you can still draw the free body diagram of each joint and solve the problem. So don't worry too much. Okay, take a look at joint C in this case. Joint C connects two members, CD and BC. Notice these two members are not collinear. They form an angle. Also notice there is no pin or roller support at this joint. This means joint C has no support reactions. There is also no applied or external load at this joint. So there are three conditions. 1, two members are non-collinear, no external load, and no support reaction. I can now put these facts into a single rule. When two non-collinear truss members form a joint and there is no external load or support reaction applied to that joint, then the two members must be zero force members. This rule confirms what we already know from our calculations. I hope you can now apply this rule to any truss problem and identify the zero force members. We will look at some examples a bit later. Now let's take a look at another scenario. I took the same problem and changed the loading condition. Now the applied load is at joint C and there is no load at joint D. Please pause the video now. Go ahead and do the calculations for the member forces one more time using the free body diagrams and come back. Okay, I hope you completed the calculations. Now that you have member forces, check which member forces are zero. You will find that members BC and CD are no longer zero force members. They carry load. But member BD is a zero force member. You will also find members DE and CD carry equal loads. So if you look at joint D, notice there are four obvious conditions. 1, two members are collinear. Third member makes an angle with the other two. There is no external load and there is no support reactions. Now I can put all these facts into a single rule. When three members form a truss joint, for which two members are collinear and the third member makes an angle with the other two, then the non-collinear member is a zero force member if there is no external load or support reaction applied at the joint. The two collinear members carry equal loads. Knowing these two rules will make your life easy in solving truss problems. Let us now take a look at some example problems and see if we can identify the zero force members quickly without doing any calculations.